Okay, there's a 1 mole. Find efficiency. Yeah. Anything, no? So it can be, later we'll see if they give a curve what to do. Now there's the basic part. What is path 1, 2? What is the path 1, 2? Isothermal, so like isobaric. Because in VT graph, if a straight line passes through origin, it should be isobaric. So here we'll write it. Isobaric, it is. Yeah. It is rejected or absorbed. Anybody wants to answer? Path 1, 2. I'm asking this one. In path 1, 2, it is absorbed or rejected. Pressure constant as temperature increases, isobaric heating. So it will be absorbed. Not respond. Yeah. Q1, 2. Okay, after this. What about Q2, 3? Isochoric cooling, it is rejected. Isobaric heating. 3, 1. Isochoric cooling. Sorry, isothermal compression. It will be rejected. Okay, now let's see that what we can do here. Area under VT graph work done. Shall I write anybody? Shall I go for that formula?
No, sir.
No, it's not be only in PV diagram. No. So therefore, better let's calculate Q. No, because if you go for work done, what is the biggest problem for you is like a for each path you should calculate work done. Again, for each path you should identify it is absorbed or rejected. Better go for Q positive, Q negative. Where all it is absorbed in 1, 2. Where all it rejected, Q2, 3 and Q3, 1. So Q positive is Q1, 2. We have that formula. In isobaric heating, 1 mole of NCP T2 minus T1. Problem is very simple. Monatomic gas, 5R by 2, temperature 3 T naught minus T naught. So this will be 5R T naught. Q negative, where all it is rejected, Q23 plus Q31. Q23, isochoric cooling, NCV, change in intensity, T3 minus T2. Q31, isothermal process. Isothermal process, what is Q equal to? NR let me save it. Okay, what is isothermal process? NR, temperature, T3, log of final volume, V1 by V3. Let's substitute all 1 mole, 3R by 2. Temperature of gas at 3, T naught, 3 T naught. 1 mole, R. Temperature of gas at 3 is T naught, log of V naught by 3 V naught. So minus 3R T naught. This will be minus RT naught log 3. What is the formula? Mod of Q positive mod of Q negative by mod of Q positive. though q positive be positive, no, so it is a practice to write mod for both. Because if I write mod for only this -1, so we may get confused. That's why we are writing it. Substitute this, that will get it. So not only this, any graph, we are in better position now. Let's not get scared. Only PV graph. Oh, let it be pressure PT graph, VT graph, Euro graph, pressure versus density graph. Let him ask. So it's not a general thermic process. Again, some of you are still asking, sir, why it is not general thermic process? So look at volume versus temperature, straight line passing through origin. So what it is a isochoric process here. If straight line doesn't pass us through origin, then it becomes general thermic process. For your understanding, if the curve is like this, no, no. Is it isochoric process? No, it's not an isochoric process. Getting this one? So if a straight line passes through origin, it's an isochoric process. What will be the slope? Let's not bother slope. So no, this is an isochoric process.
Sir,
Sorry.
isochoric must be perpendicular, sir.
Okay, wait. There's a temperature versus volume versus temperature. See, we have to ask ourselves question. We can't expect everything. Everything will be there as available. Okay, I'll just read. I'll think. I'll go. If that is the case, then everywhere scientists, everywhere in every country, crores of people by this time would have been scientists. Not possible, no. Even what I'm teaching is also what will happen. A student has to think, analyze, compare. Then he should come to conclusion. Then he can do something better. So there is no.
What is isobaric?
Sir, it is, yes, sir.
Which one?
You drew V
The
versus
line which
diagram.
passes through origin.
Isobaric. Oh, I'll change it. Isobar. It is. Not an isobaric process, not an isobaric process. So you should be careful. Straight line in VT graph, straight line passing through origin is what? Isobaric process. Agree this? So I think now you have enough some ideas, some concrete ideas are there. Digest it, start applying. So try to work out different set of numericals now. Practice them, think on them. So that open you can do better. So, okay, this is about only the graphical problems. So in chemistry, what happened? You studied. Then what happened? It was like some sort of memory, no, there was no much the method. You can't blame chemistry teacher because in chemistry book things are given like that only. Chemistry teacher will tell only that much. That's what happens in most of the in Indian system. What is there in book? Okay, that will be reflected by teacher. In physics, what happened? We do learn. So now you go back to chemistry. If they ask you equivalent graph, finish all. You do have some questions in advance. They're asking equivalent graphs. Students are thinking like again in chemistry method only. See, pressure volume, will they change in chemistry? In physics, it is a pressure volume. In chemistry, they'll become some other thing. Okay, you could have avoided this thinking. So you can take exactly all this, but work done, there the convention changes, but equivalent graph doesn't matter. No, things are same. See, here we are bothered about what I will get from gas. In chemistry open, you are bothered about the gas only. Here I'm not bothered gas, I'm bothered about like a what gas does. What is a like a effect of gas? Gas does work. Okay, that work done is what very important for me. In chemistry open, you are not bothered about the work done by gas, you are bothered about the what will happen on the gas. So therefore the conventions change it drastically. But the method is same. Isothermal process anywhere it will be same. Okay, well, I'll stop it here. Yeah, okay, I'll check it. Huh? What is the message? I don't know. Gunetra, what is that one?
Sir, I want to call you, sir.
Today, tomorrow, I'll tell you. I'll give you time. Huh?
Okay, sir.
Today,
Thank you, sir.
again, I had to. I'm going out again. For sake of class, I came. Okay, fine. Huh?
Tomorrow morning or evening, sir? Class?
Morning. Sure, ma.
Okay.
Any timings, I'll intimate. No. Yeah.
Okay.
Tomorrow morning, sharp 8 o'clock, as usual. Our timings. Huh? Okay. Thank you, all of you.
Thank you, sir.
We'll
Thank
meet
you,
tomorrow
sir.
morning. Huh? Yeah.
Thank you, sir.
Okay. Thank you, all of you. Please practice.